So this is Unit 8, Section 4 of Geometry. Today we're going to go over spheres, and we're going to learn how to find the volume of them. We're actually not going to find the surface area, so these are some of our terms that we're going to go over today. So let's just jump right into this drawing right here. So it says here a sphere is a locus of points in a space that are a fixed distance from a given point called the center of a sphere. So if I was to take a string, which would be the length of a radius, and I was able to move it in any direction, up, down, left, right, any direction, it would then touch that sphere. And we all know we don't call this shape a sphere, we call the shape a ball. And you guys are all used to dealing with different types of balls: basketballs, baseballs, soccer balls, volleyballs, all those different types of balls. So you guys usually refer to a sphere as a ball. And this right here we call the radius. Now if we had two of those and we went over to the other side, we'd have a diameter of the ball. Now we have this shape right here, which we call the great circle. So if we were to measure around the outside of a ball, that is what we would call the great circle, and that is halfway through the shape. And if we take half of the ball, we call that a hemisphere. And if we were to measure around the outside of this is what we call the circumference. And the circumference of a ball or a sphere is what we call the great circle. So let's jump right into this equation here, which is the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. Now you will notice here that it's r cubed and not r squared. So I suggest that you guys use your formula sheet, because even I sometimes forget that it's r cubed instead of r squared. And it's r cubed again because the radius is going to go to the right, it's going to go to the left, and it's going to go up or down. So this is a three-dimensional object. And when it's three-dimensional, then it is going to cube our r. So let's go ahead and use this formula now. So we have r in this problem, and this is our r right here. Our radius is 8.25. So the way I do this is I say volume is equal to, the equation is 4/3 pi r cubed. Now I'm going to show you the way I would put it in the calculator and how I would do it there. So volume is equal to, I go ahead and take this r cubed, and that's 8.25, and I cube that. And then I multiply that times 4, and then I divide all of that by 3. So in my calculator, I always cube the 8.25 first, then I multiply that times 4, then I divide that number by 3, and then I add pi at the end. And you'll notice it says to give our answer in terms of pi. So also want to remind you guys that on the quiz on Friday, it's going to ask for 2 answers for anything that has pi in it. The exact answer, which is when we have pi, because pi is an irrational number, which neither terminates nor repeats. And then when we multiply by pi, and every time we've multiplied by pi, we've had to round that answer, so that's an approximate answer. So when we round, it's approximate, and when we have pi in the answer, it's the exact answer. So let me go ahead and show you what this would be once we do it. I'll go ahead and erase this and show y'all how this would work out when we finally finish it. So when we multiply 4 times 8.25 cubed and divide that by 3, we get 749 pi. And again, it's centimeters cubed because we're dealing with volume, and volume has to do with the three-dimensional object, so we're always going to cube our three-dimensional objects units. The next one says find the radius and diameter of a sphere with a volume of 972 pi meters cubed. So this time we're going to write our formula for volume. That's 4/3 pi r cubed. This time we're given the volume, so we're going to put it over here, 972, and that's pi, equals 4/3 pi r cubed. First thing we're going to do is divide both sides by pi. When we do that, it's going to eliminate pi from both sides of the problem. So now we're left with 972 equals 4/3 r cubed. Now we got to get rid of that 4/3. Hopefully all of y'all remember the way we get rid of a fraction is to multiply by its reciprocal. So the reciprocal of 4/3 is the inverse of it. So that's going to be 3/4. So we're going to multiply both sides by 3/4. So that's going to get rid of 4/3 here and the 3/4 there. So we're going to be left with r cubed over here. So now when we find 3/4 of 972, we're going to multiply 972 by 3 and then divide that number by 4. And when we do that, we get 729. Now this next part is us getting rid of that cubed symbol. Now we know that 3 is the same as 3/1, and we know the reciprocal of 3/1 is 1/3. So we're going to multiply this to the 1, or we're going to take this to the 1/3 power, and we're going to take this to the 1/3 power. So now that gets rid of that exponent over there. So in your calculator, you're actually going to do it like this: 729 caret symbol, and do it to the 1/3, 1 divided by 3. When you do that, you should see that r is equal to 9. Now, once you get r, then you should know that the diameter is 2 times the radius, so that's going to be 9 meters. So our diameter is going to be 2 times 9, which is 18 meters. So once you go ahead and pause the video and do example 3 and 4, and then come back to me. Okay, so on this problem, the first thing we have to notice is we have a diameter here, and what we need is the radius, so we have to divide that by 2, so our radius is equal to 12. So once again, our volume is equal to 4/3 pi r cubed. So volume is equal to, I told you I would cube that number first, so I do 12 cubed, multiply it times 4, divide it by 3, and then multiply that times pi. That's going to give our answer, and our answer is 2,304 pi inches cubed. Our next one is like the previous one, and when we did this one, we wrote our equation: volume is equal to 4/3 pi r cubed. And so we're going to put 36,000 over here. 36,000 pi is equal to 4/3 pi r cubed. Divide both sides by pi first. That's going to get rid of pi there and get rid of pi there. So now I'm left with 36,000 equals 4/3 r cubed. I'm going to multiply both sides by 3/4 because that's going to get rid of the 4/3 over here. That's the reciprocal. 3/4, and 3/4 of 36,000 is 27,000. That's now equal to, that's gone and that's gone, r to the third. If you recall, I told you that when you're trying to get rid of the r to the third, you multiply that 3 times 1/3, because 3 times 1/3 is 3/3, which is 1. Do the same thing over here. So now we just have r over here. And in our calculator, again, we're going to take 2,700 to the 1/3 power. That's going to give us 30. And the diameter is 2 times the radius, so the diameter is equal to 60. And again, the unit here is meters. All right, this time when we're doing this problem, it's asking us to find the volume of a hemisphere. Now, a hemisphere is half a sphere. So the way I typically do this is I use my formula, 4/3 pi r cubed, but then I divide it by 2 because a sphere is half of a hemisphere. So I'm going to go ahead and do it this way. Now you know that you could do half of 4/3, which is 2/3, so you could do it that way as well. Most of y'all are not going to remember that, and you have the formula for a sphere on your formula sheet, so just take half of the sphere. So again, we're going to do 15 cubed times 4 divided by 3 pi. We're going to find that answer. When we do that, we get 4,500 pi, and then we're going to divide that by 2, if you recall. Because we found the volume of a sphere, then we need to find the volume of this hemisphere. So the volume of the hemisphere is 2250 pi, and again, this is meters cubed. That was our volume. So for the next problem, it asks us to find the volume of, it says sporting goods store sells exercise balls in 2 sizes, standard 22 inches diameter, jumbo 34-inch diameter. How many times as great is the volume of the jumbo ball as the volume of a standard ball. So I want you guys to go ahead and find the volumes of each of these balls and then come back to me. Okay, so the first thing you should notice is when it says up here the diameter is 22 inches, that means our radius over here is going to be equal to 11. And our radius for the jumbo ball is going to be 17 because half of 22 is 11 and half of 34 is 17. Then we're just going to basically write the formula for these two. So the radius here was 11. We're going to go ahead and populate these. So we're going to do 11 cubed times 4 divided by 3, 17 cubed times 4 divided by 3. When we do that, we're going to get the volume over here is 1774.67 pi inches cubed. The volume for the jumbo ball is 6550.67 pi inches cubed. Now the way we find this value down here, the 3.7 times, is we're going to take the volume of the bigger ball, the jumbo ball, 6550.67, and we're going to divide it by the volume of the standard ball. So that's 1774.67. Now when we divide the jumbo ball by the standard ball, we get 3.7. So a jumbo ball is about 3.7 times as great in volume as the standard ball. So now I need you guys to go ahead and do these check it out problems and then come back to me and I'll work them with you. So this first one, first thing we have to notice is that we don't have the radius here, we have the diameter. So we have to divide that number by 2, and when we do that, we get 30.95. So we're going to cube 30.95, multiply it by 4, divide it by 3. So our answer here again is going to be 39.529. And this should not be 61.9, y'all. It should be what? 30.95. Okay? So the next problem. This time, again, don't let this trip you up because all we have to do is cube the square root of 5. So we're going to plug this in. Our radius is the square root of 5. So we're going to cube the square root of 5, multiply it by 4, divide it by 3, and then add pi to the answer. Again, recall on the quiz on Friday that if it asks for exact, you're going to leave pi in the answer. If it asks for approximate, you're going to multiply by pi. So this next problem. Find a radius of a sphere with a volume of 1150.35 centimeters cubed. Now this is the one where we're given the volume. Now you should notice this time that there is no pi in that answer. So volume is equal to 4/3 pi r cubed. I'm going to put 1150.35 is equal to 4/3 pi r cubed. This time I'm actually going to divide by pi. So I'm going to divide that by pi, and I'm going to divide this by pi. So when I divide it by pi, I get 366.17 equals 4/3 r cubed, because my pi's gone from there. So now I need to get rid of the 4/3. So to do that, I'm going to multiply by its reciprocal, which is 3/4, and multiply this by 3/4. So now that's going to be gone from there. I'm going to be left with r to the third over here. And when I multiply 366.17 times 3/4, I get 274.63. If you recall, the way we get rid of that third power over here is we got to multiply it by 1/3, which means we have to do this to the 1/3 power over here on the left. When we do that, we get 6.5. So r is equal to 6.5. Now if it asked me for the diameter, I'd multiply that by 2, and that would mean our diameter would be 13. So our next problem says find the volume of a golf ball with a diameter of 1.68. So again, we're given diameter, so we have to find the radius. So we're going to divide that diameter, 1.68, by 2. That's going to give us 0.84 for the radius. We're going to cube that radius, multiply it by 4, and then divide it by 3. That's going to give us 0.79 pi inches cubed. Now, when it asks for the circumference for part B here, the formula for circumference is d times diameter times pi, and we were given the diameter up here, so all we have to do is substitute in 1.68 in, and then do pi, and that's going to be inches for our circumference. Okay, so for this next problem, we're going to find the volume of a hemisphere with a diameter of 12 inches. Again, we were given diameter, so we got to find the radius. So we're going to divide that by 2. So our radius is equal to 6. So volume is equal to 4/3 pi r cubed. And then remember, we're looking for a hemisphere, so we're going to divide that by 2. So we're going to do 6 cubed times 4 divided by 3. That's going to give us our volume for our sphere. So that's going to give us 288 pi, because this was still multiplied by pi up here. Then we're going to divide that volume by 2. Remember, this up here, we were going to divide it by 2 because we got a sphere there and we need to find a hemisphere. So our volume is 144 pi, and our unit, again, was inches, so this is going to be inches cubed. So this problem here, example 6, again, it says a giant squid needs large eyes to see their prey in low light. So the eyeball of a giant squid is approximately a sphere with a diameter of 25 centimeters, which is bigger than a soccer ball. A human eyeball is approximately a sphere with a diameter of 2.5 centimeters. And it's asking us how many times as great is the volume of the giant squid eyeball as the volume of a human eyeball. So again, we were given diameter for both of these. Notice diameter here. So we have to divide that. For the squid, the radius is going to be 12.5 because we're going to divide 25. And then for the human eye, it's going to be 1.25. Again, we got to divide it by 2. So we're going to go ahead and plug these into the formula. The squid in the soccer ball. Well, actually, it should be the squid in the human eye. I don't know why it says that. Squid in the human eye. Okay. So the squid is 6,004.17 centimeters. And the human eye is going to be 2.6. So to find out how much bigger it is, and we can kind of see this pretty quick, we're going to do 2604.17, and we're going to divide that by 2.6. And when we do that, we notice that the answer is 1001 times as great. So the squid's eye is 1001 times as great as the human eye. It's a big difference. All right, so now on this example 6, says the radius of the sphere is multiplied by 3/4. Describe the effect. So when we have problems like this, it's actually asking us the effect on the volume. So when we do that, we're actually just going to do the 3/4 and we're going to cube that. That's going to tell us our effect. When we cube 3, that's 3 times 3, which is 9, times another 3, that's 27. When we do 4 times 4, that's 16, times another 4, that's 64. So this means that this sphere is going to get smaller by 27/64. Now, if we were to find the volume of the sphere, which is what I'm going to show y'all here, find the volume of the original sphere here, which is 682 2/3 pi, and we wanted to be able to find what the new volume is, we could just multiply that original volume on the left by this volume by 27/64, and it would give us this volume over here. So we don't actually have to take 3/4 of 8, which would be 6, to find it. We could just multiply it by 27/64. So go ahead and do the check it out, which is the next one. Okay, on this one, again, the effect is 3. So we're going to say 3 to the 3rd, which means this thing is going to get 27 times bigger this time. Again, if we were to find the volume of this, we could find the volume 3 cubed times 4 divided by 3. That would give us an original volume of 36 pi meters cubed. Now, if we want to find the new volume, we can just multiply 36 times 27. That would give us the new volume. We could also do it the other way, but it's quicker to do it by just multiplying by the effect. So again, if it asks for the effect, it's actually just asking for that 27. If it's asking for the new volume, then we use the effect to get the new volume. All right, so let's look at this next problem. And again, here we're talking about the set of all points in two or more figures that have in common. That's called their intersection. And so in your blanks, you need to fill in cross section. These are your blanks right here. Cross section. That's what we're looking at here. So let's look at this first one. So if we cut a ball in half, what is the shape that we're going to see as the cross section? And what you should see is a circle. If we cut a hemisphere in half, then what we're going to see at vertical, basically a vertical cross section, we should see a semicircle. So those are our two cross sections. Now down here on the bottom says if you rotated a semicircle around its straight side. So in other words, if we took this and we rotated it 360 degrees, what shape would it create? If we rotated it 360 degrees, we would get a sphere.